Okay, good morning. Hope everybody had a good weekend. And all right, so we're gonna do. Well, the midterms already assigned or already posted, but we're gonna do some practice questions and a little review session for the second midterm today, which will be due next Monday, the following Monday. And so, just a few things before we start that. You should have saw that I sent an email and I updated a bunch of your assignment grades. And so you should see your grades for pretty much everything up to the assignments, aside from the ones that are due today, because those are still you still have time to do those. All right. So all the assignments you see here, up to example 5556, um, I I updated your grades for those. I graded those and I posted solutions. So double check those and let me know if you have any questions there about your assignments grades or anything like that. And if you missed any assignments, I do have a few more extra credit opportunities, including one this week. So if you've missed any, you can make up quite a few points doing the extra credit assignments, which are pretty much just like bonus assignments. But yeah, all these things are graded, and then these two are due today, right? Example 5.7 and example 14.1. So let me know if you have any questions on those two. But yeah, so assignments grades are up to date. Um, all the solutions for the assignments are here if you want to look at those. All right, and then we're pretty much up to date on the syllabus after next Monday, and so we'll do this one today. Well, I mean, we'll do a midterm review for midterm exam 2 today. Do some practice questions, and then on Wednesday we'll do this. So it's an extra credit assignment, but unless you've done all of the assignments and are 100% sure that you can do every single assignment, I'd recommend coming, even if you've done all the assignments, because it can't hurt, and it's nice to have extra points just in case. Or if a lot of you have missed assignments, so this will help you make up some of those. But uh, for this Wednesday, we'll just do another assignment, but it's going to be as extra credit, and that way you could make up some points if you've missed it. So this we'll do this today. Then the midterms due April 19th, and then this will also be due Monday, April 19th. All right, and then after that, we'll be caught up. Then I think all these things will be due on the due date that you see there on the syllabus, and then we're good to go for the rest of the semester, which we're about 2/3 of the way done. Okay, so we got yeah. So just this will be due Monday, the midterm, via email, right? Just like the first one, and then this will also be due Monday, and then we're caught up. Okay, so okay, so let's go ahead and start doing some practice questions and get a feel for the second midterm. So if you go to the midterm 2 section right here, okay, here's the practice midterm we're going to go through, and then here's the actual midterm that's going to be due that you guys have to do and send your answer sheet by email. But let's go through the practice questions first, and make sure if you have any questions on the type of questions or how I got the answers, make sure you let me know because the same type of questions are going to be on your midterm. Okay, so let's go ahead and open up. I think I already opened it up, but midterm 2 practice exam with solutions. Okay, so there's two big questions. One on the drug production question, we've had some practice with this one. There was a whole separate assignment for this one, so you should have plenty of practice here. And then the second one is on the forecasting sales of best chips that we did last week, I believe. And so I basically have on this midterm, there's only two questions, but they both have multiple parts, like A, B, C, D, so on. So let's go through these. And yeah, so here we go. Here's the practice exam. Okay, so you're gonna get a screen cap like this from the drug production at Repco, right? Remember we got the different drugs. Uh, you're trying to determine which one is has the highest revenue per labor hour. And then there's also some additional questions that we've done before, such as calculating the objective and some on the sensitivity report and interpreting the shadow price. Yeah. Okay. So you got this screen cap from the main model, and you got this screen cap from from the sensitivity report. All right. So you'll need both of those. First part is what we've done a bunch of times. Is refer to the screen caps of the drug production model, assuming no changes. Which drug is sold exclusively, and what explains these results. So remember, you want to go look at the screen cap, okay, and look at units sold. So here's drug A, 5,000, drug B, 0, and drug C, 0. So you can clearly see that drug A, we're selling 5,000 units of that, and none of drug B and drug C at the moment. So uh, currently, we're only selling drug A, so drug A is sold exclusively. And remember, what's going to explain that, because the only input to the only input to the production process is labor. This one must have the highest revenue per labor hour at the moment, and that's what we got to start with. So drug A is currently sold exclusively. We're only selling drug A, this company, and what explains that is always going to be revenue per labor hour, right? So that's the determining factor of what drug is the most profitable. Okay, so drug A, this explains it. That's going to be your answer once you find the drug. Okay, then the next step is you want to calculate the revenue per labor hour for that drug that's being sold. So the revenue per labor hour, the standard or the default formula is the drug selling price divided by the labor hours to make that drug, right? So just start with that, and let's do that for drug A. So revenue per labor hour is first put the selling price in there. Okay, so the selling price is 200, right? And it takes 2 hours to make, and you got to make sure that you see where that comes from. Is well, drug A is usually the easiest, but right there it takes 2 hours to make it. So this is the selling price. It takes that many hours to make it. So um, revenue per labor hour is just divide 200 by 2, and that will give you $100 per hour. All right, so $200 divided by 2 hours is $100 per hour. So that's the revenue per labor hour that you get from selling drug A, which just means that each hour that goes in um, to the production, you get $100 on sales in doing that. So you get $100 of revenue per each hour. All right, so that's for drug A, and it must be that, well, we're going to find out that the other drugs are giving you less return per hour, and that's why the company is only selling drug A at the moment. But let's figure out uh, what the other drug prices would need to go to on the market to be comparable to drug A. Okay, so B, part B, and then drug B's price needs to be greater than or equal to what for only B to be sold? Okay, so you can determine you can see that drug B's currently not giving less than $100 per hour, and so we got to figure out the price that drug B has to rise to give that. Okay, so start with the start with the basic formula, which is revenue per labor hour equals the drug selling price divided by the labor hours to make that drug. So our revenue per labor hour is equal the drug for drug B, it's the drug B price. All right, we're trying to figure out, and then here you got to figure out how many hours. It's 6, but let's make sure we see where that comes from. Okay, so for drug B, you need one drug A, and then 4 additional labor hours to make it drug B. So recall that it's 2 hours to make that drug A, and then 4 more hours. So 2 plus 4 is 6, right? So remember we did this whole process in that drug production examples. So 2 plus 4 is 6, so it takes 6 hours to make a drug B. Okay, and what you need to find out is what divided by 6, what dollar price divided by 6 hours gives you $100 per hour. Okay, and so you can just either multiply 100 times 6 or just know that you're looking for a number divided by 6 that equals 100. And so you can see that that's 600. 600 divided by 6 would give us exactly the same return as what drug A is currently getting. So this factor is what you're looking for. And that factor you're determining, right? So what divided by 6 is 100? That's 600. So revenue per labor hour equals 600 divided by 6, which would give us $100 per hour. So basically you found out that B's price needs to be greater than or equal to 600 for only B to be sold. Okay? So if drug A is 200 and drug B is 600, given the labor hours, they both give exactly $100 per hour. But look at the current situation for B, 500, right? So you can see that 500 isn't high enough. If that's the market price for B, then the company's only going to sell drug A because this gives them the better return for the labor hours that go into it. So this one's cheaper, but this one's more costly to make in terms of the labor that goes into it. So if they're not getting enough return on the market, they're just going to sell the cheaper one which is more efficient. So this is currently 500, but it's got to go to at least 600 for it to be sold compared to drug A, right? Okay, then parts or drug C is usually the most difficult just because it has the most hours and the most ingredients. But the same idea. So C's price needs to be greater than or equal to what for only C to be sold? So look at the situation for drug C. Drug C is being sold at 2,000. Now it seems like that's a uh, more profitable scenario to sell a drug for this compared to that, but it takes a lot more to make it, and so if it's too costly to make it, which it must be, then this price isn't high enough. Okay, so start with the formula. The revenue per labor hour equals the drug selling price divided by the labor hours to make that drug. So for drug C, the revenue per labor hour equals the drug C price, and then this is the thing you have to see or determine. It takes 24 hours to make it. So how do we get that? You kind of go backwards. So remember, let's see. So it takes one drug A. Drug A takes 2 hours. All right. So that one drug A takes 2 hours. We determined that drug B takes 6 hours. Okay. So it takes 6 hours to make that drug B. So it's essentially 2 plus 6, which is 8. And then 16 more hours is 24. Right. So this one takes 2. This one takes 4. 2 plus 4 plus 16 is 24. Okay, so see how that all adds up. So first determine the hours that go into making the individual, I guess we can call them ingredients, because you need drug A and drug B to make drug C. And then look at the additional labor hours once you get those drugs to go into the laboratory or whatever and manufacture it into drug C. So 2 plus 6 plus 16 is how we got the 24. Okay? All right, so it takes 24 hours to make a drug C, a whole day. Um, so given that it takes so long, uh, what would the drug have to sell for divided by 24 to give us the same return as drug A, which would be $100 per hour. All right, so all you're doing here is either multiplying 24 times 100, okay, which is 2400, or just um, determining what divided by 24 equals 100. So you can see that the revenue per labor hour, if the drug C price was 2400, that's the turning point. So 2400 would be the price divided by the 24 hours that go into making drug C. That gives us the same return um, of $100 per hour. Okay, so drug C's price needs to be greater than or equal to 22,400 for only C to be sold. All right, and you're looking at the current situation that's only being sold for 2,000. So this one um, wouldn't be comparable unless it goes up to a market price and consumers are buying it at 2,400. All right, given the labor intensive process to make it. Okay, so what we've determined here is that drug A's revenue per labor hour is 100, right, given its selling price. So what's the comparable point for the other ones? Um, so if drug C is 200, drug B is 600, and drug C is 2,400, they're all giving that same return of $100 per hour. But you can see that we need to get a higher price for drug B of 600 and a higher price for drug C of 2,400 to be comparable to that. All right, so that's the story there. All right, so the parts D, E, and F are on the objective and some constraints and shadow prices. So parts A, B, and C, we did a bunch of examples there, and if you want to make sure you understand the concepts, I'd recommend going through these ones. Okay, as the assignment drug production, there was I think 5 questions we did for practice. So just for practice for this problem, I'd recommend just not looking at the answers and going through those and making sure you understand those for practice. But I think we get the idea for this type. Questions on how to do this analysis for the different drugs, right? Just trying to find the prices and the revenue per labor hour. Okay, everyone good on this analysis here? Okay. Okay, then part D is going to be given the current parameters, calculate the objective. So this is just using the drug that's sold, right? Because these parts B and C were hypotheticals. You're just trying to figure out why B and C were not being sold, and you figured that out. But right now, only drug A is being sold. So the revenue for this problem is going to be, or the objective is the revenue from sales, which you're maximizing. And given no changes, the current situation, the company's going to get revenue from the drug it sells. So it's not selling drug A. Sorry, it's not selling drug B. It's not selling drug C right now. So it's only selling drug A. So that means that the revenue we get is just how much we get from selling drug A. So we sell 5,000 units of drug A at $200, right? So that's the only component for revenue. So it's going to basically be each drug A is $200. So 5,000 of those times 200 is our revenue. So the units sold times the selling price. Okay, so revenue from sales is the unit selling price times the units sold. And remember, it's only the one that's being sold, not the other ones that are not being sold. So this is only for drug A because you determine the drug A is the one that's being sold. So the unit selling price times the units sold, and the revenue from sales is $200 for drug A, selling. Okay, that's from right there. And uh, units sold, 5,000 from right there. All right, so those are the only two factors you need to calculate the revenue here. So 200 divided by 5,000 is a nice even $1 million for this company. All right, so for this one again, depending on the question, make sure you're only doing the calculation for the drug that's being sold. So it might be on your take-home exam, it might be drug B, it might be drug C, but you can determine that by the unit sold. So only calculate the revenue from the drug that's being sold, not the ones, because there's no revenue from nothing being sold for these two. So this is zero, and this is zero unless the market prices go up, right? So only from this one for now. Okay. Part E. All right, so we've done this a bunch of times, not recently, but um, quite a few times. List each constraint and then is the labor hour constraint binding or non-binding, and we can calculate the slack for the labor hour constraint only. So remember this, we'll list the constraints, and if it's binding, and if there's slack, so you can kind of set up this little chart. There's going to be two constraints here, basically these two. So any inequality range is a constraint. So you have the production constraint right there, and you have the labor constraint. So you can say that essentially the units produced have to be greater than or equal to the units used in production. All right, so you can't produce more than you have in production, which makes the model solvable. So the units produced have to be greater than or equal to the units used in production. So you're just interpreting this constraint here. So that's number one. Units produced greater than or equal to units used in production. And that's for units A, B, and C. You can just group them together kind of like this. Because I know that the units produced for each of the drugs is technically it's the units produced for A bigger than or equal to the units used in production for A and the units produced for B, but you can just summarize it like this. Units produced greater than or equal to units used in production. So that explains this constraint. Then the other constraint is the labor constraint. We can't use more than what we have available for labor, so the hours used have to be less than or equal to hours available, right? You're explaining this one here. Yeah, so hours used, then second one, less than or equal to hours available. So these are going to be your two constraints for this question. And this one, don't worry about interpreting because it doesn't, because the constraints that are associated with the decision variable don't have a clear interpretation. You need them to solve the model. So see how like this side is 0 and this is 5,000. So this is necessary to explain and to do the solver, but don't worry about interpreting constraints that are connected to the decision variables, the red cells. But the labor constraint, you got to interpret that. So it'll tell you in the question, is the labor hour constraint binding or non-binding? Okay, so that's for this one. And then calculate any slack for the labor hour constraint only. So it tells you that uh, only list the constraint for this one and don't worry about interpreting. You can just leave it blank or put uh, not applicable like this for the first one. But this one, you want to see that, well, it's binding because you use it all, right? So if if you use all of what's available, so there's 10,000 available, and the company used 10,000. So that means they used all the hours available, so that constraint is binding. Right? So if you use all of it, it's binding. And there's no slack because there's no difference. So slack occurs when what you use is less than what you have available. Here, that's not the case. We used all 10,000, there's nothing left, so there's no slack. Okay, part F. Interpret the shadow price for the labor constraint in range B23 to D23. So you're only doing it for the labor constraint is all it's going to ask. And so if that's for this constraint you described, and that's for this constraint right there, right? So you're talking about this one, and the shadow price should be available in the sensitivity report. This screen cap. All you need from the screen cap is that shadow price right there, 100. And so the constraint right side 10,000, and the final value 10,000 should be exactly what you see right there, what you do. So this shadow price applies to this constraint, and you can double check that the numbers on the left side 10,000 are the same as the hours on the right side 10,000. But all you need from this sensitivity report for this question is that shadow price for the labor constraint, the hours used, okay? And so what does that $100 shadow price mean? So to interpret that, that's the value of one more hour. So the shadow price here is 100. And what that means is if the drug company gets one more labor hour and uses it in production, revenue from sales will increase by 100. So the shadow price is always the impact on the objective. If you get one more of the right side, one more unit of the right side, in this case labor hours. So if you get one more labor hour, your uh, objective is going to go up by that shadow price. So one more hour, then revenue goes up by 100. So the value of one more labor hour is $100, right? So if the drug company gets one more labor hour and uses it, the revenue from sales will increase by 100. And that should make total sense given what's going on with drug A, right? Because what did we determine? We determined that the revenue per labor hour is $100 per hour, right? So clearly, if you get one more hour, you're going to get another $100. So the the what I'm trying to tie in here is that the shadow price should be the same as basically each hour of the drug that's the revenue per labor hour you're comparing to. So see how this should make total sense given that, because we know that each hour for making drug A gives us $100. So if we get another hour, what does the shadow price tell us? We get another $100, which is 100% correct. Okay, so the shadow price ties right into what you determined for revenue per labor hour, and that should make what you did in the first part nice and interpretable. Okay. So so the shadow price is really important here because it kind of comes full circle and explains the revenue per labor hour. All right. Yeah. Okay. So that is the full practice question for number one. Um, questions on any of these parts? A, B, C, D, E, F for number one. Okay. Number two is going to be the one that you're similar to the one we did last week, the forecasting sales of best chips, which is the exponential growth spreadsheet. So here's a formula you can use. All right, so you'll get some historical data for the years and the sales, and you get the predictions for these sales for a linear model and exponential like we did uh, in class, but different numbers, and then you'll have some absolute percentage errors, and then I think the boxes that are blank right here are most likely what you're going to be calculating. Okay, so I think you're going to calculate these cells, and also probably try to determine what the next year's uh, or what one of the year's sales is using the different models. Okay, so there's the linear trend line with the equation, and there's the exponential trend line with the equation. Okay, so you got the main screen cap, or you got the equation for the absolute percentage error. You got the main screen cap, you got the linear graph, and you got the exponential graph. So you got to use those pieces to answer this question or this type of question. All right, so refer to the screen cap of the exponential growth model, and using the linear model, let's go ahead and calculate the absolute percentage error, the APE for year 10. All right, so make sure you're doing the right year. It's probably the one that's blank. So for year 10, you want this one, okay? And the APE is just the absolute value, the absolute percentage error of uh, the actual minus the predicted over the actual. So it's the difference over the original, right? So use the same formula. Okay, so the APE for year 10 is equal to the actual sales in year 10, 315, right there, uh, minus the predicted sales for year 10 for the linear, and that 291 comes from right there, okay? So you're looking here, you're trying to get the year 10, make sure you're on the same um, row. All right, so there's the actual, there's the linear prediction, so use those numbers. So we're trying to calculate in percent-wise, essentially how far off this was from that, right? That's all we're doing. So this was, the actual was 315, linear predicted 291. What was the percent off from that? Okay, and then this is the actual sales, which are 315. So the difference over the actual, which would give you this minus that over that, and make sure so this will be in decimal terms, and if it's negative, make sure you remove the negative sign because this is the absolute percentage error. So absolute just means take the absolute value. All right, so this one you'd get, actually wouldn't be negative, it would be like 0.076, okay? And in percent terms, that's 7.6%. Okay, so multiply your decimals by 100 to get the uh, percentage. All right, so do the calculation, take away the negative, and then make sure it's in percentages. Okay, so 0.076 is about 7.6%. B, let's do the same thing for the exponential. All right, then using the exponential model, calculate the APE for year 10. So same formula, but we're comparing it to the exponential this time. So here we are, same row, year 10. Here's the actual 315, but the exponential predicted 317. So you can clearly see that 317 is much closer to 315 than 291 was. So we don't know. I don't know exactly what it would be without looking at it, but this one should be closer, which means that it should have a lower error because this was only $2 off and this one was 24 dollars off or something like that. Okay, so here's the prediction, or here's the actual. There's the exponential prediction. So how far off was that from that? So it's this minus that divided by that. Okay, so we're doing the same calculation, but we're comparing the exponential for this one. All right, actual sales in year 10, 315, minus predicted sales in year 10 for exponential is 317 divided by actual sales 350. Okay, and so this one, because this number is less than that, this would come out to something like negative 0.006. Okay, but you want the absolute percentage error, which means the absolute value of the error, and so take away the negative. So when you put this in the calculator, if you don't have the absolute value feature, you got to do it manually. So there should be no negative signs for the absolute percentage error. So if it's negative 0.006, take the absolute value and then multiply it by 100, and that should give you 0.06%, so pretty low, which means, like you see, that this number was very close to that, and in fact, less than 1% off. Okay? All right. Part C. Which model predicted the sales better in year 10? Um, Obviously the exponential here, because 0.6 error is less than 7.6. Okay, and so you're comparing the errors and double check that your finding makes sense. It does here because this one, 317 compared to 315, was much closer than that one. So you should already know, kind of just looking at the spreadsheet, that this one did a worse job of getting to that than this one did, but you're just verifying that. Okay, so this one's obviously a lot closer than that. Um, D, calculate predicted sales for year 12 using the linear trendline parameter. So you're gonna be given, like we are here, the uh, equation for each of the types, the linear and the exponential. So the linear one is right there. Okay, so start with that. All right, so you're basically saying that right, y equals 58.02 plus 23.28 times x, and here y is sales and x is time or year. So it asks for uh, the predicted sales for the linear in year 12. So sales in year 12, all right, so equals 58.02. That's the intercept from the equation, right? Right there. Plus the slope from the linear equation, which is 23.28. Okay, that's right there. And then x is time. And this is time, it's asking for year 12. So time 12, so put a 12 in there for x. Okay, so this part's given, and then put in the appropriate x because it asked for year 12. So if it asks for year 11, put in 11. If it asks for year 10, put in 10. So don't always put in 12 unless it specifically asks for 12. Because we're trying to see each additional year what happens on average to sales. So put this in your calculator and you'll get something like $337.38. Okay, and again, might want to look at the graph and see that if that looks right. So you're predicting what year 12 is on this line, right? So does that look like 337? Let's see. So go with, yeah, that looks pretty good, right? So that looks like about 337. So that looks right. So if you get something that looks, oops, sorry, that's the wrong one. But this one, yeah, that looks like about 337 over there, right? And so if you get something that's in the appropriate range, it's probably right. But if double check if you got something that said like, you know, $2 or $5,000, then that's clearly not right. So make sure it's going to be somewhere in the range on the graph, right? And so make sure that the calculation you get looks like it's the right one. So we want this point on the graph for year 12. So that's like going right there. So that looks right. Okay. Part E. let's calculate predicted sales for year 12 using the exponential trend line parameters. So sales in year 12. Okay, now we're using this equation, so exponential. So start with this, y equals 86.43 times e raised to 0.13 times x. Okay, so you should be able to put this in your calculator with the number e, or use an exponential, or just get the estimate for e, which is like 2.17. Yeah, 2.7. So if for some reason you don't have a calculator or a method to calculate e, which I'm sure you do, but if you don't, you can just use the like 2.7. This is the number. So that's what e is there. Okay, so you're using this equation to get predicted sales for year 12. So sales for year 12 equals 86.43, so that's that number, and then times e, right, raised to 0.13 times, all right, so this is given. The only thing you got to plug in is x, and know that x is 12, okay, for year 12. So for this one, whatever the year is, that's what x is. If it's year 11, put in 11, and so on. But in this case, put in a 12, so this number, 86.43 times e, raised to 0.13 times 12. All right, so make sure you double check your math here, and maybe do this part first, and then multiply it by that. But this is the full equation. And if you calculate this whole thing, that times that in your calculator, you'll get something like $411.30 for the exponential for year 12. Okay, does that look right? You're getting this number. Does that look like 411? Yeah, that looks like it, right? So it looks like it's on the chart. Okay, it looks like that could be 411. All right, so that looks good. Okay, now part F. What does the slope of the linear curve imply exactly? So now you're interpreting what that 23.28 means, or whatever this number is. So you don't need to interpret mathematically what any of these numbers means, because it's kind of, this is the formula, but it doesn't have a direct linear interpretation because it's nonlinear. But for this one, all right, it's clear. So the slope of the linear curve is 23.28. Whatever is multiplied by x here is going to be your linear slope. So what does that 23.28 mean here? So the linear slope is the effect on y if you increase x by 1 unit, right? That's always the interpretation. In this case, y is sales and x is time. So if you increase time, if you go +1 in a year, that's the effect on y. So the effect on y is $23.28, or 23.28. So what this means is, over the 10-year data set, sales increased by $23.28 per year on average. So that means, on average for this data, using a linear prediction, each year we got on average an additional $23.28 increase in sales. So see what that means? So this line is what you're interpreting. So the slope of this line is $23.28. So each year, on average, plus 23.28, plus 23.28. So that's what this, right? If you can simplify it to an average increase, then the average increase is that. Okay, so each time you increase x by one more year, that's what you can expect sales to increase by $23.28. So for year 11 and 12, we just basically added an additional 23.28 per year. Okay, that's all we did there. But it's important to see what that uh, curve means. Okay. Um, for number 2, okay, you're going to have one similar like that on your take-home midterm 2. Any questions? Any questions on this one? A, B, C, D, E, F. How did you get these answers? Okay.
I'm good.
Great. Okay. Um, all right. So that is the review. That's the practice midterm. Let me pull up the actual midterm, and there's gonna be 2 questions, 50 points each, but different different numbers, but same number of parts and same type of questions. So you can use this one as a reference. If you're gonna cut and paste stuff, make sure you pay attention to what's on the actual exam as opposed to what was on the previous one. Okay. All right. Here's your midterm. So there's the practice one we just went through, and if you look here, midterm 2, spring 2021, there's a PDF. Okay. And the PDF is missing you can use the PDF with the screen cap for the trend lines here. It's missing the data points. Something happened in the conversion, but it's pretty much the same thing. So these are both the same tests, but I'm going to pull up the Word document because I know that the screen cap the graphs are full. So here's the PDF version or the Word document. You can use either one. Okay, so here's your exam for midterm 2, and just like the first one, you can make sure you show all your work in your answer sheet. Okay, it's worth 100 points, so it's the same. Each exam is the same amount of points, so I can't remember exactly what I said here, but yeah, so each exam is 15% of your grade, so they're all the midterm 1, midterm 2, and final exam uh, are all worth 15%. All right, so the each exam is worth the same. All right, so this just like it says in the syllabus, and also like it says here on the actual test, you're going to submit your answer sheet via email. Okay, so email it to me by next Monday, week 12, Monday, April 19th. There's my email address that you've all used before. And if you could put your answer sheet in a PDF or Word document, that would be the preferred format for me to look at and grade. So you're going to email me your answer sheet in PDF or Word document if you can um, by next Monday. Or you can, whenever you're done, you can email it to me whenever. So you don't have to wait until Monday. You can send it to me tonight or tomorrow or this weekend. But I need to get it by next Monday. And yeah, okay. So here you go. Here's the first question. Okay, you got a drug production question. You got the screen cap there. You got the sensitivity report, and then you should see that the questions are familiar to what we've gone through. All right. So do the revenue per labor hour analysis, objectives, constraints, and then shadow prices. And then number 2, okay, this is like the best chips one we just did. So you're gonna have some data. You're gonna calculate the missing predictions and the missing APEs. All right, so there's your linear um, graph with the equation, and there's your exponential graph with the equation. All right, and you're gonna calculate the APEs for whatever it asks. you're going to calculate the predictions and then interpret the slope. So make sure you, whichever year or uh, value it asks for, make sure you do that one. So if it asks for year 9, do year 9. Okay, so uh, any questions on what I want you to do for the exam? And just make sure you send it by email next Monday. Okay, so uh, questions on the actual exam? Everyone good on this?
Yeah, I'm good.
Okay,
Wait, I have a quick question.
yeah,
Could you go over the non-binding and binding?
sure. Yeah,
Yeah.
yeah, no problem. So let me just pull up this one again. Okay, so for this question, the only constraint you're going to interpret for binding non-binding um, is this labor hour constraint. And so remember, the constraint is binding if you use all of what's available, and it's non-binding if there's something left over. So see how this one, so like if uh, the reason why it's binding here is because there was 10,000 available and you used 10,000. Now, if there were 10,000 available and you only used 9,000 or something less than 10,000, it would be non-binding. So it's binding if essentially this number that you use equals what was available to use. Okay, so you're going to look here for binding for the labor hour one and see what this number is. And if you used exactly that number, if this number equals that number, then it's binding. If this is less, if this is 9,000, 8,000, something less than 10,000, that's going to tell you that it's non-binding. And then if it's non-binding, you're going to have slack. And the slack is going to be the difference between what was available and what you use. So like if this was 8,000, it would be non-binding and the slack would be 2,000. If this was 7,000, it would be non-binding and the slack would be 3,000. So it's only non-binding if they're equal. And I'm sorry, only binding if they're equal like we are here, if we used it all. And if it's binding, you know that there's no slack because there's nothing left. Does, does that does that make sense?
Yeah. Yeah.
Okay. All right. So yeah, so on the exam, do that same process. Just look for what you used, compare it to what's available, and if you use it all, binding. If this is less than you didn't use it all, it's non-binding, and then you got to calculate the difference, which is going to be the slack. Okay. Okay. Uh, any other questions on the specific parts of the exam or anything else that relates to midterm two? Okay. All right. So there's your midterms on Blackboard. Right here, midterm under midterm spring 2021, midterm two spring 2021. To make sure you don't do the practice one because we already did that one. So this is you can use the PDF or the Word document, the same exact thing, whichever you prefer to use. And make sure that you email me that um, by next Monday, April 19th. Okay, and then yeah, so that's correct. And then on Wednesday, we're going to do this one, the extra credit time series, which is also going to be due Monday, April 19th. So I know it says extra credit, but just think of it as like another assignment. If you missed any assignments, or even if you haven't missed any, it's possible you might not have time for one in the future. So I'd recommend coming. It's just like another assignment. So we'll do this one on Wednesday, and that'll be due on Monday as well. So make sure you do this first. We'll do this one on Wednesday. They'll both be due on the April 19th, and then we'll be all caught up. And we'll start doing the rest of this stuff, the last third of the class, after the midterm, or I guess next Monday. Okay, and then last thing, make sure you get these two assignments in today if you haven't done that. Okay, I think that's what I had planned for today. I guess we'll finish a little bit early, but I just wanted to make sure we got a good review session for the exam, and it seems like everyone is good to go with the exam. But all right, so I think that's it for today. Let me know if you have any questions about the exam, but I'll see everyone on Wednesday, same time, and thanks for coming.
See you, Mr. President.
Thank you, and yeah, you too, and have a good rest of your week.
Yes, you too.
You too.
Thank you.